Rates are numbers that represent two quantities that change in direct proportion to each other. Anytime you have a unit with the word per in it, you've probably got a rate. Kilometres per hour, dollars per hour, litres per minute, cents per kilometre. Solve problems involving rates by using ratios, with one column to represent each quantity. Ask yourself, what does the rate mean? And be careful with units. Make sure they match before you do any other calculations. Let's try some examples. Ben travelled 340 kilometres in 4 hours. What was his average speed? Well, let's set up a ratio. Speed is about distance and time. Ben went 340 kilometres in 4 hours. Notice how I put headings at the top of each column and put each number from the question carefully under the correct heading. Okay, so how do I find the average speed? Well, if I want my answer in kilometres per hour, then it's just the distance travelled in 1 hour. How do I turn 4 into 1? Divide by 4, obviously. So divide the distance by 4 as well. 340 divided by 4 is 85. Ben's average speed was 85 kilometres per hour. Try another one. Emma took 2 hours to go from home to her uncle's farm. She travelled at 90 kilometres per hour. How far away is the farm? Now, I know some of you may know the formula for speed and may want to just rearrange the formula to get the distance. But I want to show you how you can use ratios for a problem like this and not have to worry about whether you got the formula right or what you need to do to it to rearrange it. Just set it up exactly the same as the last one. Distance and time, and the speed is 90 kilometres per hour, which means Emma goes 90 kilometres in 1 hour. But she took 2 hours for the trip. 2 is double 1, so double the distance, 180 kilometres. See how the ratio allows you to solve this problem without worrying about turning a formula around? You just put the numbers in the right places, guided by the headings at the top of the columns, and then work out the one number you're missing. The same method works no matter what it is that you're trying to work out. Let's try a few more. Rebecca is planning her holiday. She has to travel 980 kilometres to reach her first destination. To complete the drive in 11 hours, without considering break times, what will her average driving speed need to be? Distance and time, 980 kilometres in 11 hours. I want the speed, so I want the number of kilometres in 1 hour. 11 divided by 11 is 1, so divide 980 by 11. It's 89.090909, a recurring decimal. How many decimal places do I need here? Well, she's just planning a drive, so really the nearest whole number will probably do. 89 kilometres per hour. But what about if you don't know the time? Jessica travelled 1,015 kilometres from Brisbane to Mackay. How long did it take her to make the journey if her average speed was 95 kilometres per hour? Well, start with what we do know, 95 kilometres in 1 hour. Now I need 1,015 kilometres. So, multiply by the new number over the old. 1,015 divided by 95. How many decimal places should we have? Let's go for 2. 10.68. It will have taken Jessica 10.68 hours to drive from Brisbane to Mackay. Now, I've seen some students do strange things with that kind of answer. They want to write 10 hours, 68 minutes. And then realising that's wrong, some of them will even change it to 11 hours and 8 minutes. No, it isn't 68 minutes. It's 0.68 of an hour. Turning that into minutes is a whole separate problem. Let's leave it as decimal hours for now. What about other rates beyond just speed? Let's try some problems involving rates of pay. Sarah works for 8 hours and earns $76. Calculate her rate of pay. Okay, set up a ratio. What are the variables here? Amount of pay and length of time worked. Sarah was paid $76 for 8 hours. How much would she be paid for just 1 hour? Divide by 8. 76 divided by 8 is $9.50. She earns $9.50 per hour. Chloe earns $15 per hour. How much will she earn for a 6-hour shift? Yes, I know some of you want to just multiply them, but I want to show you how this works using a ratio. $15 for 1 hour. How much for 6 hours? So multiply by 6. 15 times 6 is 90. Chloe will earn $90 for a 6-hour shift. See how the same method works, and you don't have to try to figure out whether it should be a multiply or a divide. You just put the numbers in the right columns and it falls straight out. Anne earns $12 per hour. How long will she have to work to earn $100? $12 in 1 hour. $100 will take how many hours? Well, multiply by the new number over the old. 100 over 12. 8.3 recurring. Let's go for 2 decimal places again. Remember, that's not 33 minutes. It's a third of an hour, which is actually 20 minutes. But just leave it as a decimal for now. Anne will have to work for 8 1/3 hours to earn $100. Sometimes the units will be different, and you'll have to convert them first before you do anything else. Try this example. Tomatoes are selling for $3.50 per kilogram. How much will 750 grams cost? How much can you buy for $20? First, how much will 750 grams cost? The variables here are the cost and the mass of tomatoes. It's $3.50 for 1 kilogram. How much for 750 grams? See how on the right I have kilograms and grams? If I'm not careful, I'm going to end up with a very wrong price. If the units are different, change them to be the same first before you start. Either turn the kilogram into grams or the grams into kilograms. It doesn't matter which, both work fine. But 1 is easier to work with in a ratio than 1,000. So let's leave the 1 alone and convert the 750 grams into kilograms. There are 1,000 grams in a kilogram, and a kilogram is bigger than a gram, so I need less of them. Divide by 1,000, which is 0.75 kilograms. Okay, now, what do I do to 1 to get 0.75? Well, that's easy. Multiply by 0.75. So do the same to the cost. 3.5 times 0.75 is 2.625, which we need to round to the nearest cent, $2.63. The second half of the question is easier. How much can you buy for $20? So again, set up the ratio as before, $3.50 for 1 kilogram of tomatoes. Now I have $20, put that in the cost column. What do I do to convert $3.50 into $20? Multiply by the new number over the old. So do the same to the mass. 1 times 20 over 350 gives me 5.714 to the nearest gram. You can buy 5.714 kilograms of tomatoes for $20.